We're going to start learning about chemical quantities now and learn how to calculate different amounts of a substance. So we can measure substances by measuring their mass or their volume or by counting the number of pieces that they have. If we're going to measure mass, we do it with a scale in the lab, and the scale gives us that mass in grams. If we measure something's volume, it is measured in liters. If we're going to determine or count the number of pieces something has, the unit we use is a mole. So a mole is an amount of something, and it's actually defined as the number of carbon atoms that you would find in exactly 12 grams of carbon-12. So carbon on the periodic table, this is the isotope 12, so that would be its 12 atomic mass units. So if you took this most common isotope of carbon and you put it on a scale until it weighed 12 grams, that would give you 1 mole of carbon, or 6.02 times 10 to the 23rd atoms of carbon. So 1 mole is equivalent to this number, 6.02 times 10 to the 23rd representative particles. So you can think of it kind of like a very large dozen. If I was to say I have, 1 dozen apples, you would know in your mind that there was 12 apples there. So if I were to say I have 1 mole of carbon, you would know that there are 6.02 times 10 to the 23rd atoms of carbon there. And this number is called Avogadro's number. So just to sort of wrap your brain around it, again, a mole is just an amount of a substance. So if I say I have 1 pair of shoelaces, you know that there's 2 laces. If I say I have 1 dozen oranges, you know there are 12 oranges. If I say I have a gross of pencils, you know there's 144 pencils. If I say I have a ream of paper, that's 500 sheets of paper. So if I say I have 1 mole of something, you know there are 6.02 times 10 to the 23rd representative particles. Now, the question is what is a representative particle? So a representative particle is the smallest piece of any substance. So if we're talking about, a covalent compound, the smallest individual piece of a covalent compound is a molecule. So, if I have, a big cup of sugar, 1 individual sugar molecule, C6H12O6, is going to be a representative particle. An ionic compound's representative particle is a formula unit, and an element's representative particle is an atom. So if I had 1 mole of table salt, sodium chloride, that means I would have 6.02 times 10 to the 23rd formula units of sodium chloride. If I had 1 mole of carbon dioxide, I would have 6.02 times 10 to the 23rd molecules of carbon dioxide. Now, when we think about the elements, we have to keep in mind our diatomics. So there are 7 diatomics, and we know that whenever we find them in nature, they're not alone. They always come with a little buddy. They exist in pairs. And remember, those are Mr. Brinkelhoff, so bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So for those elements, their representative particle is actually a covalently bonded molecule. Now let's kind of do a few examples looking at some of the math that we need to use to go back and forth between these different amounts of things. So let me open up the Elmo here. Okay, so we have I've got some problems, some example problems here. So let's just look at this one right here, number 9. So number 9 says, determine the number of atoms that are in 0.58 moles of selenium. Okay? Let me zoom in a little bit so you can see that better. So we use unit analysis to convert from one to another. Moles is the unit we're starting with, and we want to end up with numbers of atoms. And in order to make this conversion, we have to use a conversion factor. So remember, we learned this in the first unit, that conversion factors are equal to 1, and the conversion factor that we just learned is that 1 mole of something is equal to 6.02 times 10 to the 23rd representative particles. So we're going to start by writing what we have. We have 0.58 moles of selenium. Remember, this is how you actually abbreviate moles as MOL. And I'm going to multiply by a conversion factor so that I can go from moles to atoms. Now, selenium is just an element, so its representative particle is an atom. So I'm going to put the mole on the bottom because I want the mole to cancel it out. So 1 mole of selenium on the bottom. And then on top, I'm going to put Avogadro 6 times 10 to, and in this case, it is atoms of selenium. So my moles will cancel. And to figure out how many atoms I have, I'm just going to take this number and multiply by this number. Let me grab a calculator quick. So I have 0.58, and then multiply by, and remember to punch in my number in scientific notation, I'm going to do 6.02 EE to the 23rd, and hit equals. So my answer is 3.49 times 10 to the 23rd atoms of selenium. That's what I have in my sample. All right, let's do another one where I actually go another direction. So this one says, how many moles of barium nitrate contain 6.8 times, and this E right here means times 10 to the 24th, formula units. So in this case, I'm given the representative particle. Remember, formula units, or FUs, is the representative particle of an ionic compound, barium nitrate. So I'm going to start and I'm going to write what I have. So I have 6.8 times 10 to the 24th FUs of barium nitrate. And then I'm going to use my conversion factor. This time I want the mole on top because that's what I'm trying to find, and I want the representative particle on the bottom. So I'm going to say 1 mole of barium nitrate is 6.02 times 10 to the 23rd FUs of barium nitrate. Because remember that an FU is the representative particle for an ionic compound. So my FUs will cancel. And let me just punch in this number. So 6.8 EE to the 24th divided by Avogadro's number, 6.02 EE to the 23rd. And I get 11.3 roughly. So 11.3 moles of barium nitrate. Okay, I'm going to do one more quick example. So let's do number 11, but I'm going to change it a little bit here. Let's say it says determine the number of molecules that are in 1.25 moles of oxygen. I want to say let's determine the number of atoms. That'll make it a little bit more difficult. So remember that I have moles here and I have oxygen, and oxygen is a diatomic, so its representative particle is a molecule. So I'm going to start and I'm going to write I have 1.25 moles of O2, and I'm going to make my conversion factor. So I'm going to put the mole on the bottom because I want it to cancel, and then I'm going to put the representative particles up top, 6.02 times 10 to the 23rd, and that's molecules of O2. Because it's a diatomic, its representative particle is a molecule. Now if I wanted to take that extra step and go from molecules to atoms, then I'd have to say, well, how many atoms of oxygen are in each molecule? And the answer is 2 because of the subscript of 2. So I would say 1 molecule of O2 has 2 atoms. This would cancel, and then I could plug in and find out how many atoms I have there. So 1.25 times 6.02 EE to the 23rd times 2, and I get 1.5 times 10 to the 24th. So 1.5 times 10 to the 24th oxygen atoms. Okay, so that last one's a little bit more challenging. In the next video, I will move on and talk about mass to mole conversions.